Hello, and welcome to Controllers Tech. We have covered so many displays in the past, which includes the cheap SPI-based displays, intelligent HMI displays, and the ones embedded by ST on their boards. Every display has its own advantages and disadvantages. Cheap displays are cheap, but it's very hard to program them and find a compatible library. HMI displays are a bit costlier and it's easier to interface them, but most of them are missing a solid designer platform. Then the ST provides everything you need, a decent display, a solid designer software, and it comes with a price tag. But again, they don't provide higher resolution displays, and also the form factor of the board is quite large, so a practical application is very hard. Today I have another display with me, which is manufactured by the company called Riverdi. They are specialized in manufacturing different kinds of displays, and yes, it includes the one based on STM32 MCU also. Here you can check the STM32 embedded displays. They generally provide the 7-inch and 10.1-inch STM32 based displays. Riverdi has sent me one test unit, which is this one right here. It is a 10.1-inch TFT display, with a resolution of 1280 by 800 pixels. It is based on the STM32H747 MCU, with 2 MB of internal flash, and 1 MB of RAM. Other than that, it also has the 64 MB of quad SPI, and 8 MB of SD-RAM. And the best thing about this is that it has the official support from the TouchGFX. This is how the controller board at the back of the display looks like. You can see it has the ports for different peripherals, like FD CAN, RS-232, 485, and one for the USB. This here is the power port to power the display. It also has a Rebus connector to connect other Rebus displays manufactured by the Riverdi. Here is the SWD port to debug the MCU, or to load the program into it. There is one expansion connector, which gives us access to other peripherals, like I2C, UART, SPI, PWM, ADC, etc. Before we go ahead with interfacing the display, let's see the unboxing first.
Hello, my name is Kamil, I'm CEO and founder of Riverdi, and today we will be unboxing our latest STM32 Embedded Display in a size 10.1 inch, which is already available on our webshop and through our distribution network. So let's see. When you will buy a module from Riverdi or our distributors, you will buy it in the single package module like this one that I have here, and I'm gonna show you what you will get inside, what is included in the package and what is not included, that you may need also to use this display. So first, when you open the box, you will see the package with the cables and the jumpers. So let me show you what we have here. We have two cables. One is a power cable and one is a programming cable, which is pretty important. So let's start first with the power cable. So we have a Molex 5-pin, and in a second version of a display it will be 6-pin power connector, which on both sides has a Molex connector, but in most cases you will need to cut this cable and connect it to the power supply to connect the power to the display. But the Molex cable for the board is included. And the second connector and the second cable we have here is a Molex to IDC connector, which is a programming cable, and it's already prepared for a Stelling programmer version 2, which is the most common ST programmer right now on the market. That is not included, of course, into the display package, but you can use this cable connected directly to the STM programmer, and then use this small Molex connector and connect to the board and start programming the display, which we will show in another video, how to start programming the display. Okay, so let's have a look into the box. What else do we have? Of course, we will find the display there, so let me take out this one and see what is in there. The display that I have here is the most sophisticated one, which is equipped with a touch screen that is optically bonded to the display, so it's like fully equipped version. So with the board, with STM32 H7 microcontroller, all the memories, all the iOS connectors, and the touchscreen that you can see here. So I have a display right now, and I will connect it because the display that you will receive from us is already, of course, tested and programmed with the demo application to show you how does it work. So here I have the cable that I already prepared with the power supply. I took a typical 12 volt power supply, but the power voltage on the connector is pretty wide. It's from 6 to 30 volts, so you can check this in detail in the data sheet, of course, but I use the 12 volt, which is very typical power supply that I have. I have a connector here, and I will connect it right now. And what we should see is a demo application that I mentioned is already programmed. So as you see, I already have it, and of course then we can use the touchscreen as well. It's programmed and it's ready to play with. So you can receive this display and immediately check its performance and of course the touch performance as well. So this is all for today. You know already and now what to expect when you will buy a single module display from us with STM32. So as I mentioned, you will have the power cable and you will have the programming cable in the box included, so your start to work with our display should be very fast and easy. Okay, so I wish you fantastic projects with our displays, and please order them from our website or from our distributors network. Okay, thank you very much for today. Bye bye.
This is the back of the display, and here you can see the controller board. This here is the power port, and this one is the SWD. We have the USB port, the RS485, and RS232. There are two CAN ports, a coin battery connector, and the rebus connector. You can also see the three buttons on the top left corner. The two buttons are user buttons, and the third one is to reset the board. There is also a micro SD card connector. And lastly we have the expansion connector to connect other devices, or to use the I/O pins. Let's see the documents provided by them for this display. We have the datasheet, the drawing, and a 3D viewer file. There is an option to customize the order, and a getting started page. In the customization page, you can customize the order as per your need. One important point I want to show here is that you can customize the cover glass even up to 6 mm and more, so it allows to use the display even outdoor. The Getting Started guide focuses on TouchGFX, and how to program the display using it. Since that's what I am covering in this video, let's close it for now. We will see the datasheet in a while. This 3D file I downloaded earlier, I have AB Viewer installed to see it. This is how it looks in the AB Viewer. Basically you can see the details of all the components used in the display. Well, this could be extremely useful for designers, and for mechanical engineers in the designing process. Let's check the datasheet now. Here you can see the naming convention of the display. This includes the company name, the display standard, the screen size, resolution, etc. Here, as per the electrical characteristics, the display can work with wide range of voltages, typically ranging from 12 to 36 volts. I am using a 12 volt 1 ampere adapter for it. Alright, now let's talk about the ports. First we have the power port. If you see here, the pins are numbered on the ports, and below we have the details of the pins. In the power port, we basically need to connect two pins, one for the power supply, and another to the ground. This pin number 4 can be used to enable or disable the power supply, but by default this pin is enabled. If you want to turn off the display, you simply need to connect it to the ground. I am going to leave this pin open, as it is anyway internally connected to the VDD. You can see the pinouts for other ports here. For now I am interested in SWD. Here you can see the connections for 6 pins, and we need to connect them to the exact same pins on the SD link. Here you can see my power connector. I have only connected 2 pins, one to the VCC, and another to the ground. This is the connection to the SD link. Here I have connected all 6 pins to the respective pins on the SD link. Now we will simply connect the SD link to the SWD port, and power connector to the power port. Next is the rebus connector, just in case if you need to connect another display to it. Then comes the backlight setting. You can connect external display via the rebus connector, and select its backlight power source. It can be internal 5 volts, or the main power supply. For details, please check the documentation. Here is the pinout for the expansion connector, and these are all the peripherals you can access with it. There are 2 user push buttons connected to PC6 and PB0. Also there is a user LED connected to PJ10. That is all the information there is in the datasheet. Let's start the TouchGFX and design an application. I am going to design a simple application, just to show you how to get started with it. For the rest, you can use all the TouchGFX features as mentioned in my other videos. Make sure you use the new version, at least 4.20 onwards. Here click on Create New, and search Riverdi. You can click on the result, and read about the display on the right. This is the 10.1-inch display that I have. Let's give some name to the project, and click Create. First of all I am going to add a background image. Here I already have a ping image of the same resolution. Let's add this image to the project. Next I am adding a slider, and a gauge to this screen. Slider can have values, from 0 to 100. Configure the widgets as per your need. Now we will add one interaction to this screen, which will be called when the slider value has changed. This will basically call a new function, slider updated, which we will later write in our IDE. The idea here is that the gauge should move as we change the slider. To do that we will write a small code in the IDE. The designing part is finished, so generate the code. You can also run the simulator to see if everything is as per your design. Right now the slider is not changing, because we haven't programmed it yet. Now go to the files. Here in the main project folder, open the Cube IDE folder. Now open the project file in the Cube IDE. Alright, the project has been loaded. Our entire project will be in the Cortex M7. Here you can see the main.c file. Notice that the script already initializes all the peripherals, whether you use them or not. We are not working with the main file right now, so go to Generated, and open the Screen 1 View Base. Here you will see the function which we defined in the interaction. Go to the definition of this function, and copy it. Now go to the GUI folder, and open the Screen 1 View. We need to first define the function in the header file, so paste it here. Now we will call our function in the Screen 1 View class. This will be basically called whenever the slider value changes. And here we will update the gauge with the same value. To do that, we will call the gauge.setValue, and pass the value of the slider to it. Now invalidate the gauge, so that new value can take effect. This is it. Let's build the code now. Let's first check in the simulator if it is working or not. You can see the gauge is updating as per the slider value, so we are good to go. Now comes the important part, about how to load the program into the display. As per I have been told, there are two ways to do it. You cannot load it via the Cube IDE. You can directly load it via the TouchGFX, or use the Cube programmer to do it. But even before that, we first need to copy the external loader into the Cube programmer directory. If you see here in the project structure, there is a STLDR folder. It contains the external loader we need, so open this folder and copy the loader. Now go to the directory where the Cube programmer is installed. In my case it is in C, Program Files, STMicroelectronics, STM32 Cube, STM32 Cube Programmer. Here go inside the bin, and then External Loader. Now paste the loader here. I already have it, so I will just replace that one. You just need to do it for the first project. Now I am going to load the project using the TouchGFX, but we need to restart it first, or else it will not see the loader. Alright, let's load our project. Now click the Run target to load it to the display. It takes a lot of time to build and load the project. Alright, it's finally done now. You have to press the reset button at the back to reset the display. Here we have our project. Let's see it in action. You can see the gauge is responding according to the movement of the slider. The slider and gauge, both are very responsive in their movement. So this is working very well. You only need to load the project once from the TouchGFX. Let's say you modified the code and rebuilt the project, loading it from TouchGFX takes a lot of time. So now we will see how to load it via the Cube programmer. Here you go to the debug folder. This file, flash.bin, is generated whenever you build the project. So now we can just load this file, and it will not take as much time as with the TouchGFX. Open the Cube programmer. Connect the SD link. Now go to this download section. Make sure the address is 08 million hexa. Browse the flash.bin file we just saw. And click Start Programming to program the board. Remember that this will only load the code to the internal flash, so the QSBI is unaffected from it. I just showed you a very simple application for this display, but as I said, you can use everything that I have covered in the TouchGFX playlist. Now, one very important thing you have to keep in mind, even though they provide the IOC file, it is not advised to generate the project from it. You can refer to it for the pin connections, but do not generate the project from it, or else it simply won't work. As I mentioned in the beginning, the script they use pretty much initializes all the peripherals and components, so you just have to directly call the functions provided in the library. Like here is the SD card driver, and you already have the function like init, write blocks, read blocks, etc. Or here you can see all the files for SD card, LED, buttons, flash, etc. So you just have to analyze this project structure, and use the functions provided to you. This is just like how SD provides the examples in the repository. Before we wrap up this video, let's see the demo project for this display. Go to TouchGFX, and create a new project. Select Demos, and click Board-specific demos. Here are the demos for the Riverdi boards. Click Create to create the demo project. Here the demo project has been created. Now just run the target from here to load it on the display. Here you can see the project is running well on the display. So I hope you understood how to get started with the Riverdi STM32 based displays. The advantage you can have with it is that there already is a solid designer software available for free, and we already know the capabilities of using STM32 as the controller. You can purchase the display from Riverdi website, and there is no minimal order requirements, so you can order even a single piece. The displays are also available in offer from the biggest distributors like Mouser. The link to the website is in the description below. The link to download the code is in the description too. This is it for this video. Keep watching, and have a nice day ahead.
Want to learn more about Riverdi products? Please visit our page riverdi.com. Feel free to contact us if you have any questions. Our team is always there to help and guide you. And please remember to subscribe Riverdi YouTube channel. See you later in our next video.